Okay, today is day 2 of Arithmetic Sequences series, which it's really not because yesterday, or I should say the last lesson, was Arithmetic Sequences. This is Arithmetic Series. So to quickly explain to you the difference between a sequence and a series, A is an arithmetic sequence. It follows the pattern of minus 2, minus 2, minus 2. B also follows the pattern of minus 2, minus 2, minus 2, but it's the sum of all those terms. That's a series. So we wrote explicit rules for sequences. Today we'll do the same thing. We'll find solutions, or we'll find for some of the first 25 terms or whatever of a series. Okay? So once again, an arithmetic series is the expression formed by adding the terms of an arithmetic sequence. So let's look at the first equation, then we'll come back to the formula. So it says, consider the arithmetic series, 20 plus 18 plus 16 plus 14 plus ... Find the sum of the first 25 terms. So if I asked you to go ahead and do this, I'm sure some people could just figure it out at some point by saying, okay, I'm going to get the list going. I'll get up to the 25 things and I'm going to add them, right? But what if I said 250 terms? Then that's going to take you a little bit longer, right? A lot longer. So there's got to be a quicker way than doing it the way that most people are thinking of at first. Okay, so the quicker way of doing that is to use this formula. The sum of the first n terms of an arithmetic series is, you take the number of terms. So if I want to find the sum of the first 50 terms, that'd be 50. And then times the quantity of the first term of that series. So whatever the first term is, plus the last term, in this case of the example I just said out loud, the 50th term, and then dividing that by 2. So that's our formula. And this S sub n on the left side, that's just the notation for the number of terms. So like if you wanted to find the sum of the first 50 terms, I'd say S sub 50 is equal to 50 times whatever the first term is plus the 50th term divided by 2. Okay, so let's go ahead and try our example here. Find the sum of the first 25 terms. All right, in order to use the sum formula, I need 3 things. What are those 3 things that I need? Number of terms, first term, and the nth term. So let's see if I have those 3 things. Number of terms. Find the sum of the first 25 terms. Got that. Good. I need my first term. 20. Got that. I need my 25th term. Oops. Didn't write that right. A sub 25. I need my 25th term. I don't have that. So yes, I could figure out the pattern and continue it. But like I said before, what if I asked you for the 250th term? That would take too long. So we know how to find the 25th term of anything, of any arithmetic sequence. Any arithmetic series. All that we have to do is write a rule and then plug in 25. So what are the 2 things I need to write an arithmetic rule? I need the first term, 20, and I need the difference. We got the difference. What do I do to a 20 to get it to be an 18? 18 to get a 16, 16 to get a 14. It's always minus 2. So now I can write my rule. Remember, for an arithmetic sequence, the rule is A sub n equals your first term, which is 20, plus n minus 1 times the quantity, or times the difference, negative 2. Clean that up. 20 minus 2n plus 2. So your rule that pattern is following is negative 2n plus 22. Now, the whole reason I wrote the rule is because I want to know what's the 25th term. So negative 2 times 25 plus 22. That's negative 50 plus 22, which is negative 28. So I know this is negative 28 now, and now I can use my sum formula. So sum formula is super easy. Sum of the first 25 terms. This is just notation, that left side. Like it's not numerical. It doesn't mean anything numerically. So you're going to take the number of terms, which is 25, times. So notice this is a skeleton right here. That will always be there. The parentheses with the plus divided by 2. All right, my first term, 20, plus my 25th term, negative 28. All right, now You can use a calculator on this, but on this particular problem, you don't need one. You can do the mental math, but we're going to do the mental math out loud just so that when you go to type in your calculator, you type it in the same way that you would do the mental math. So what you're going to do first is you're going to do 20 plus negative 28, which is negative 8. Then you're going to divide that number by 2, which is negative 4. Then you're going to multiply that number by 25, which is negative 100. That's the same way you would do it if you were using a calculator. So if it was, 250 times the quantity of 800 plus 7,627 divided by 2, then you would do it the same way. You would add the two numbers in the numerator, divide it by 2, and multiply it by 25. Also, this answer should make sense because if you look at it, these numbers are getting smaller and smaller and smaller. So at some point, the negatives are going to overpower the positives. All right, there is a part B to this. So you're using this arithmetic series again, okay? Find n, so find the number of terms such that the sum is 108. So this time I gave you S sub n. So I gave you this right here. So I gave you, that's 108. I want to find the number of terms, so I'm looking for n. All right, I need the first term. Given to you, 20. All right, now remember, this was 25, and this was the 25th term. So this is n. I need the nth term. I already know the nth term. It's right here. So negative 2n plus 22. Negative 2n plus 22. All right, now I need to clean this up. So the first thing I'm going to do is I'm going to clean up this numerator here. So I have 108 is equal to n times the quantity of 20 and 22 is 44. So negative 2n plus 42, not 44. All right, now I'm going to look to see if these two numbers are divisible by 2, which they are. So I'm just going to divide that out. If they weren't, I would do a different method, which I'll show you in a minute. So divide by 2, divide by 2. 108 is equal to n times the quantity of negative 2n divided by 2 is negative n. 42 divided by 2 is 21. All right, so now I'm going to clean this up. I'm going to distribute that n. 108 equals negative n squared plus 21n. All right, so now I should notice that this is a quadratic with an n squared and an n. So I want to try to factor it. In order to try to factor it, it has to be equal to 0. I want to try to solve by factoring, but it has to be equal to 0 first. So I'm going to get everything on one side. I'm going to get everything on the left side because that n squared is negative, and I don't want to work with the negative n squared. So now I have n squared minus 21n plus 108 is equal to 0. All right, I need to factor this. I'm looking for two numbers that multiply to give me 108 and add to give me negative 21. Now remember, you can use a calculator to find these. Okay, so you need to start with 1, that's fine. 1 goes in there 108 times, but no, that's not it. 2 goes in there 54 times, but no, that's not it. Soon you'll work your way up to 9 goes in there 12 times. Now they have to multiply to give you positive 108, which is happening, but add to give you negative 21, which they're not, so I'm going to make them both negative. So that's n minus 9 times n minus 12 equals 0. And I get n equals 9 and n equals 12. Okay, now both of these are answers because it's saying if you add the first 9 terms, you get 108. But also if you add the first 12 terms, you get 108. Realize because since your numbers are getting smaller, this number is going to increase for a while, but then it's going to start to decrease. So that's why you get two solutions. Will you always get two solutions? Absolutely not. Also, if I would have gotten n equals negative 9 and n equals 12, the negative 9 wouldn't work because I can't have the sum of the first negative 9 terms. That makes no sense. Okay, so the next one, find the sum of the arithmetic series. Okay, so I want to find the sum of this series. Now I could, once again, fill in the blanks. But what if this said 5,926 right here? You really want to keep going on with that pattern? Absolutely not. So let's do this the quicker way. Let me get rid of that 26 too because we're not doing that. Okay, So I need to know, I want to use this formula right here because it says sum, right? So I'm like, all right, I want to use that formula right there. So I need to know the number of terms here. Do I know the number of terms? No, I don't. Now let's say, okay, well, what else do I need? I need to know the first term. Do I know the first term? Yeah. Do I know the last term? Yeah. A sub something is 59. I don't know what it is. It's a sub like something. But I know that. So the only thing I don't know is how many terms there are. So I could figure that out. So I'm going to start writing this down. I'm going to say the sum of the first, I don't know how many terms that is. I'm not going to put it in there because I'm going to end up figuring it out. Equals, once again, I'll just leave a blank spot here. I don't know what n is. First term is 3 plus last term is 59 divided by 2. All right, I need to know how many terms there are. Well, I know this is the first, this is the second, this is the third, this is the fourth. What's this? How can I figure it out? Well, if I knew the pattern it was following, I could figure it out. In other words, if I knew a rule, I could figure it out. So what we're going to do is we're going to write a rule. To write a rule, we need the first term and the difference. The first term is 3. The difference is 4. So let's write our rule. A sub n is equal to our first term, which is 3, plus n minus 1 times our difference, which is 4. Distribute combine like terms, so 3 plus 4n minus 4. So the rule that it's following is 4n minus 1. All right, so I want to know if the term is 59, what number term is that? All right, I'm not plugging in 59. It's not the 59th term. I want to know what number term 59 is. So add 1, that's 60. Divide by 4, so now I know it's the 15th term. So now I can say, all right, I'm finding the sum of the first 15 terms. This is 15. And now I can figure that out. So I'm going to do 3 plus 59, 62. Divided by 2, 31. Times 15, which I have no idea which that is, but you can use your calculator the whole time. It doesn't matter. So the sum of the first 15 terms, after using my calculator, I get 465. Okay? Now, once again, you might be saying, I did a different way, but my way was faster. I just filled in the missing blanks, and then I added them all up. Okay, well, once again, if I change this to 5,926, your way is not going to be faster, right? We want to make sure you know how to do this with any numbers. We're using small numbers just to start here. All right, next one, find the sum of each series. Okay, we already know what this means from yesterday, or maybe it was not yesterday. You know, a previous lesson. It says plug in 1, plug in 2, plug in 3, plug in 4, plug in 5, all the way up to 25, and then add up all those answers. That seems like a lot of work, okay? Whenever it seems like, that seems like a lot of work, it's because there's a faster way of doing it. We can use the sum formula. To use the sum formula for an arithmetic sequence, we know that it's arithmetic because it's following a linear pattern, right? This is linear, 7n. That means that it's increasing by 7. It's plus 7, plus 7, plus 7, plus 7. So we can use our arithmetic series formula. To use the arithmetic series formula, you need 3 things. You need the number of terms, you need the first term, which is a sub 1, and you need the last term, which is a sub 25. Okay, let's figure those out. How many terms am I finding the sum of? 25. What's the first term? Well, that wasn't given to me, but I can plug in 1 here to figure it out. 7 times 1 minus 2 is 5. So my first term is 5. Now I just need to know my 25th term. So I'm doing 7 times 25 minus 2. That's 173. So now I can use my sum formula. The sum of the first 25 terms is equal to the number of terms, which is 25, times the quantity of the first term, which is 5, plus the 25th term, which is 173, divided by 2. I'm going to use my calculator to do this one. I'm going to put 5 plus 173 first, hit enter, divided by 2, enter, times 25, enter. And I get the sum of the first 25 terms. It's 2,225. Okay? This one right here, is this an arithmetic series? Yes. How do we know? 3n minus 5. It's linear, okay? So since the equation is linear, it's arithmetic. All right, so I can say I can plug in 1, 2, 3, 4, all the way up to 200, and then add them all up. It sounds like a lot of work. So that means that I'm using my sum formula instead. Now, if it was just 1 through 2, I'd be like, I'm plugging in 1, I'm plugging in 2, and I'm adding them, all right? Now, 1 through 200, a lot more work. So in order to use the sum formula, I need 3 things. I need the number of terms, which is 200. I need the first term, and I need the 200th term. All right, first term, I plug in 1 here. I get negative 2. I plug in 200. That's 600 minus 5. I get 595. And now I can use my formula. The sum of the first 200 terms is equal to number of terms, which is 200, times the first term, negative 2, plus the 200th term, 595, divided by 2. Once again, I'm going to use my calculator to get this answer. I'm going to add these two, divide it by 2, multiply it by 200. So I get the sum of the first 200 terms is 59,300. Now, you might have somehow stumbled upon that some of your calculators can just put this in your calculator the way it looks. It is way more important to know how to use this formula than it is to plug this into your calculator. Now, it is nice if you do know how to plug this into your calculator also. So if you did figure that out, good. But please make sure you still know this formula. Okay, so here it's in a word problem sense. And then after that's just practice. So if you're like, I got it, after this problem, that's fine. If you want to see a few more practice problems or pause it and try these on your own, that's great. Okay, so this one says, the corner section of a football stadium has 15 seats in the first row, and it has 40 rows in total. Each successive row, so each row after the first row, contains 2 additional seats. So the first, there's 15, then 17, then 19, then 21. How many seats are there in this section? Okay, so we want the total, we want the sum. In order to use the sum formula, we need 3 things. We need the number of terms. We need the first term, and we need the last term. Okay, so we know that there's 40 rows, right? We know that there are 15 seats in the first row. How many seats are there in the 40th row? Not given to us. So we have to say, okay, well, I need to find a sub 40. How can I find a sub 40? I need a rule. All right, so we're going to have to start back at the beginning here and write a rule. In order to write a rule, you need 2 things. You need your first term and your difference. Your first term is 15. Your difference is that it contains 2 additional seats, so it's plus 2. So let's write our rule. A sub n is equal to 15 plus n minus 1 times 2. 15 plus 2n minus 2. So the rule is 2n plus 13. All right, now we can figure out how many seats are in the 40th row. 2 times 40 plus 13. There are 93 seats in the 40th row. So now we can use our sum formula. So the sum of the first 40 rows is equal to 40 times 15 plus 93 divided by 2. Once again, we can use our calculator to get this answer. We're going to add these 2 numbers. We're going to divide that by 2, and then we're going to multiply it by 40. So you get S sub 40 is equal to 2,160 seats. That's the total number of seats in that section. Okay, so like I said before, the rest of this is practice. If you're like, I'm good, you can go ahead and move on to today's notes. If you're like, I'm going to pause this and try these on my own before I start homework, I think that's also a good idea. I'll go through them in just a minute. Okay, so this first one here says, consider the arithmetic series. Find the sum of the first 100 terms. Okay, so sum, first 100 terms. To use the sum formula, I need to know the number of terms, which is 100. I need to know the first term, which is 2. And I need to know the 100th term, which was not given to me. So I need to find a sub 100. In order to find a sub 100, I want to plug in 100 into an equation. That means I got to write an equation first. So my equation is a sub n equals my first term, which is 2, plus n minus 1 times the difference. So I look for a difference, plus 7, plus 7, plus 7. So 7 here. A sub n equals 2 plus 7n minus 7. So the rule is 7n minus 5. Now I can find the 100th term. Oops. I can find the 100th term by plugging in 100. And I get that is 695. Okay, so now I am ready to use my sum formula. Sum of the first 100 terms is equal to 100 times the first term, which is 2, plus the 100th term, which we just figured out is 695, and then that divided by 2. Put it in your calculator, add these two, divide that by 2, multiply that by 100, and you get the sum of the first 100 terms is 34,850. All right, next one, find the 500th. Find the 500th term of the sequence. All right, so I want to find a sub 500. I want to plug in 500 into my rule, which I already wrote. So that is 7 times 500 minus 5. 3,500 minus 5, that's 3,495. And that's my 500th term. Notice it doesn't say the sum of the first 500 terms. It doesn't say the sum of the first 500 term. All that they want is the 500th term. Okay, next one. Find the sum of each series. All right, so if I want to find the sum, I need to know how many terms there are, which I don't know this time. I need to know my first term, which is 2, and then I need to know my last term, which I just don't know what number that is, but it's 34. All right, so I need to know how many terms there are here. In order to figure out how many terms there are, I need to write a rule. In order to write a rule, I need the first term and the difference. So I'm going to do a sub n is equal to the first term, which is 2, plus n minus 1 times the difference. That's plus 4, so 4. So now I know the rule is 2 plus 4n minus 4. So my rule is 4n minus 2. So now I need to know, how does 34 fit into this pattern? I need to know what number it is. So I'm going to set that equation equal to 34. I get 36 equals 4n, so that is my 9th term. So there's 9 terms here. That's being my 9th term. All right, so now I can use my sum formula. The sum of the first 9 terms is equal to 9 times the first term, which is 2, plus my 9th term, which is 34, divided by 2. Once again, I'm going to add these, then divide that number by 2, and then multiply that number by 9. So you get the sum of the first 9 terms is 162. All right, next one, I see sigma notation, and I know that I'm going to plug in 1, 2, 3, all the way up to 150. Too much work. That means that I'm using my sum formula. So, can I use my arithmetic series formula for a sum? Yes, I can, because this is arithmetic. It's linear. All right, so I know that n is 150. I know that a sub 1 is, I have to figure that out. And a sub 150, I got to figure that out. So I'm going to plug in 1 here. 2 times 1 is 2, plus 4 is 6. Plug in 150 here to figure out the 150th term. 2 times 150 is 300. 300 plus 4 is 304. So now I can use my sum formula for the first 150 terms. 150 times 6 plus 304 divided by 2. So I'm going to do 6 plus 304 divided by 2 times 150. And I'll get 23,250. All right, last one in this review here. Find an explicit formula. So they want me to write a rule, the arithmetic sequence, so I know it's going to be linear. Given the 7th term is 50 and the 15th term is negative 22. So remember to write a rule. I need the first term, which it was not given. I need the difference, which it was not given. So I was, however, given that the 7th term is 50 and I was given the 15th term is negative 22. So remember, a rule is just a linear equation. With these 2 points, I can write a linear equation. So first off, I need the slope, which is the same thing as the difference. Negative 22 minus 50 over 15 minus 7. All right, negative 22 minus 50 is negative 72. 15 minus 7 is 8. Divide those two and you get negative 9. So that is D, that's your slope. Okay, now I'm going to use y minus y1 equals m times x minus x1 to write an equation of a line. Then I'll convert that into a sub n form. So I have y minus, I'll pick this one as my point here because the numbers are smaller. Well, I guess negative 22 is smaller, but you know what I mean. Y minus 50 equals m, which is negative 9, times x minus x1, which is 7. Okay, so I have y minus 50 is equal to negative 9x plus 63, and then add 50 to both sides. And I get y equals, so I'm going to put a sub n equals negative 9n instead of negative 9x plus 113. There's my rule. All right, once again, not the only way. If you look back at the notes, I use elimination, which is longer. All right, if you haven't already, please get started on that homework.